Hello, and welcome to this, my video on length of an arc and area of a sector. Yes, I know, could it get more exciting? My name is Darren from Maffs Guru. Really good to see you. Thanks very much for watching. If you can do me a favour before I get into all of this and subscribe to my YouTube channel, it really does mean the world to me. And again, this is my needy moment where I will cry in a moment. Why does it mean so much to me? Well, because who watches Maffs videos? Every time someone who watches these videos clicks and subscribes, it lets me know that actually I'm not sitting in a room with the dog in a corner talking to myself, right? He doesn't talk to me, and talking to these videos is just random at the best of times. So if you can do me the honour of just subscribing to YouTube, it means the world to me. Also, let your mates know, your teachers know, etc. I know it's not cool to put out a Snapchat, but oh, and look, I've got merch. Mugs are going really, really fast. So grab a Maffs Guru mug. I get like 63 cents from the sale of a mug. It's not like I'm going to be rich or famous. Right, these are my learning objectives. And if you want to know, everything I write on behind me is downloadable from Maffs Guru as well, which is absolutely free to sign up. And there's VCAR questions and all that jazz as well. So we're going to build on my last lesson. All right, now I thought this was funny. Yeah, what is that a picture of? It's an ark. It's Noah's Ark. Yes? Yeah, I know. All the animals 2 by 2 went onto the ark. I would not have wanted to be the person who had to sweep up all that poop. That would not have been a fun job, yeah? And how did he stop the animals from having a go at each other? I take my dog for a walk. He's already barking at like all the other dogs. Put him on a ship with an elephant and oh, it would get messy. Anyway, I diverge. We are building on our, measurement, scale, and similarities lesson. And we've done Pythag, we've done area and perimeter, and we've done rounding. And if you haven't watched those videos, again, head over to Maffs Guru, and they will be there, all sequenced along with the Cambridge textbooks. And thank you very much, Cambridge, for letting me use your examples. Whew, I feel like I'm advertising every time I do that. Right, finding the arc length. Well, obviously we're not going to be using Noah's Ark. An arc length is basically a section on the outside of a circle. There we go. There is a beautiful example of an arc length that I am highlighting. A to B, outside the edge, is an arc length. And believe it or not, all the way around the other way is also an arc length. So we'll come back to that another time. Now, to be able to find the arc length, we've got to realize it is just a fraction of my circumference, isn't it? Because this is the circumference of my circle, and this bit here is just a fraction of it. But what fraction? Well, I think of this as pi. Oh God, I'm hungry again now. Why do I always talk about food when I'm doing my videos? All right, but the point of it is, this here is a pi slice, and we know the angle of the pi. Well, we must have this fraction here of my whole circle, which is 360 degrees. So if we look at what the formula is for arc length, we use the letter S, no idea why. And we have some fraction, some theta on 360 degrees. Again, this is nothing more than a fraction of my whole circle. So that's saying, well, we've got some angle out of 360, and I'm going to times it by 2 times pi times r. Hold on a moment, 2 times pi times r. That looks familiar. Yeah, it's the formula for my circumference. So what we're really saying is we have a fraction of my circumference. For those of you who are like, what is he talking about? Pause the video, watch it again. I thought that was a really good explanation. Otherwise, all you need to know to find the arc length is the angle and the radius of my pi slice. Now, we try and confuse you by saying the angle subtended. It just means this angle in here, so don't get tricked, okay? All right, here's an example. Look at this. In the circle with a center point O and the radius 10 centimeters, well, there is some important information. The angle subtended at O, basically it just means the angle here, okay? By arc ACB. What on earth does it mean, arc ACB? It just says go from A through C to B. That's the arc that we need. Has a magnitude of 120 degrees. Could we throw any more confusing language into this? Magnitude is just size. It just says the size is 120 degrees. Find the arc length, or find the length of said arc. Well, we know the arc length is given by theta on 360 times 2 times pi times radius. And obviously you would have that in your summary book, wouldn't you? Because if you can't remember it, that's okay. So what angle did we have? Well, the angle was 120 degrees out of 360. That's my fraction of my circumference, which is 2 times pi times my radius of 10. Cannot be working that out in my head. Likewise, don't think I've left enough room for my calculator, so let's move this over. Fire at me, Kaz. And there we go. Let's see what happens. So what do I want? I want 120 divided by 360. Hit enter. I'm going to times that by 2, times it by pi. So there's my pi button on my calculator. And times it by 10. Hit enter, and out comes. Oh, we've got to do it to one decimal place. Always good to make sure that you know what decimal, what accuracy. 20.9. And we want it as centimeters. Again, this isn't an area. In this situation, they wanted the length of the arc. And basically, that's pretty much it. They could try and trick you. How could they trick you? They could want you to find this arc length. Well, there's two ways of doing it. I could find the whole circumference now and take away 20.9. Or I could use the same formula and this time just have that angle there as 240 degrees. You're going to say, why 240 degrees? Well, if this is 120 and they all add up to 360, that there would be 240. So there's lots of ways of thinking about these questions. Oh, here we go. That cake, does that not look good? Right, slices of pie and cake and pizza. I am driven by food. Yes, what you don't notice is that actually I've got a filter on that basically sucking it all in because my tummy. Right, I'm feeling hungry. We can find the area of a sector. Now, an area of a sector is just basically the area of a pie slice. So once again, if this here is my pie slice and I wanted to find the area of it, I'm really looking for a fraction of the whole area. Well, we know therefore that the fraction once again is given by theta on 360. The reason it's 360 is there's 360 degrees in a circle and we've got just a little bit of it. We've just got that fraction of it, itchy head. All right, what am I going to do now? I'm going to times that by I want a fraction of my area. And I know the area formula is pi times r squared. Oh, look, that's what we got here. So it's a fraction of the area of a circle. Let's hide that pi because I'm now really hungry. In this circle with a center at point O and a radius length 10, the angle subtended at O by arc ACB has magnitude 120 degrees. Find the area of the minor sector. Well, basically, that's just saying the small part of the cake. All right, there is a minor sector and a major sector. A sector is just a slice of cake. The minor sector, it would make sense, therefore, is the little bit. So let's do that now. So part A, the area we know is the angle, which is 120 degrees, divided by 360, because that's the whole circle. So there's that fraction of pi times my radius squared, which is 10 squared. Let's put up my calculator. Let's see what we come up with, shall we? We've got 120 divided by 360. I'm going to times that by pi. And I'm going to times that by 100, which is 10 squared. And lo and behold, what I get? 104. What's my accuracy? 2 decimal places, 0.72 centimeters. And because it's area, it has to be squared. Right, what about the area of the major sector? Well, again, this was me saying a moment ago that, let's put my highlighter on. The major sector is just the bigger part of the cake. So if I was inviting you over to mine for, that sounds really creepy, so we won't go too far with that one. But if I was inviting you out for my birthday and I was going to share my cake, trust me, you would be getting the green bit. I'm getting the orange, yellow bit because I'm really hungry now. All right, but the point of it is, what angle is that one there? Well, the whole circle is 360. That's already 120. So the angle I'm looking for now would be 240 degrees. So in which case we've got the area is equal to 240 divided by 360 times pi times radius squared, which is 10 squared. I know my calculator's in the way, but I'll move it in a moment. Let's use it though. So we're now going to do 240 divided by 360. Now times that by pi and times that by radius squared, which now gives me 209 points, still to do decimal places, for 4 centimeters squared. Now again, as I said earlier, there are other ways of doing it. I could, having got this area here, found the area of the whole circle and taken away the area I'd already found. Now the reason I don't like doing that is if I'd made a mistake here randomly, the chances are I won't make the same mistake here. And if I do, well, I've made a mistake. Find the area of a sector that subtends. Now, there's no diagram here. So again, we've got to know the language. Find the area of a sector that subtends an angle of 73 degrees at the center of a circle with a radius 34. Right, again, I'm just going to draw a pie slice. I'm not drawing the whole circle. I know that there is 73 degrees. It tells me the radius is 34. What does it want me to do? The area of a sector. Okay, so the area is going to be 73 divided by 360. So there's that fraction of the area of my circle, which is pi, times radius squared, which is 34 squared. So again, to fire up my calculator, I've got 73 divided by 360. I'm going to times that by pi. I'm going to times that by 34 times 34. Gives me 736.1 decimal place, 4 centimeters squared. Now, a word of warning, my munchkins, if you are out there still listening, we can trick you now with perimeter questions. Right, now, I know I've got an area example here, but when you are finding the arc length of something, you are only finding this. What if I wanted to find the perimeter of that shape there? What if I wanted to find the perimeter of the pie slice? Well, you'd have to find the arc length and then add on to it 2 lots of 34. And so many people get tricked. In the previous video, I told you that if you were trying to find the perimeter of a semicircle, you'd find the perimeter of the circle, halve it, but you'd have to add on that diameter as well. Otherwise, you are in all sorts of trouble. And believe it or not, that is it. I am done. It is done for this video. There is so much for you to practice. Thank you very much for watching. Darren from Maths Guru. Again, if you can, sign up to my YouTube channel. Tell your mates, tell your teachers if you found this useful. And there's a lot of dodgy resources out there, other videos that people are using. So hopefully you and your teachers can use this one instead. More videos on the way. Look forward to seeing you in that. If not, please take care and ultimately stay safe.